For example 3, it says, find the intervals of increase and decrease for the function g of x is equal to x over x squared plus 1. So, step 1, we're going to find the derivative. And we're going to say that g prime of x is equal to, we're going to use our quotient rule here. Remember that we have the low d high less high d low, draw a line and square below. So we're going to take our low, our d high less high, and our d low, and draw a line, and we're going to square that denominator. Then we are going to simplify this. We're going to combine the like terms on the numerator. And then we're going to factor that numerator using a difference of squares. Then we're moving on to step 2, our roots. Remember that we're doing our roots from our numerator, and from our denominator. In our numerator, we get x is equal to 1 or negative 1. In our denominator, we can square root both sides. And the square root of 0 is still just 0. So x squared plus 1 is equal to 0. We can move that positive 1 over. And when I try to square root here, there is no solution. So all I'm looking for is for negative 1 and positive 1 with my interval when it's less than negative 1, when it's between negative 1 and positive 1, and when it's greater than positive 1. And then we move on to doing our chart. So I have 3 intervals. I have 2 factors in the numerator. I have 1 factor in the denominator. And then I have my f of x and my g of x. Sorry, it is g prime of x. Let's use the right one. And my g of x. And my intervals from negative infinity to negative 1, from negative 1 to positive 1, and from 1 to positive infinity. When I sub in a value that exists in these intervals, I get a positive, a negative, and a positive. I get a positive, and a positive. And I get a negative, a positive, and a positive. What is happening in these regions? Well, in the first one, it's less than 0. In the second one, it is greater than 0. And in the third one, it is less than 0 again. What's happening to my original function? It is decreasing, it is increasing, and it is decreasing. And then lastly, we're going to do our statement. And we're going to say, therefore, g of x is decreasing when x is an element of negative infinity to negative 1 or 1 to positive infinity, and increasing when x is an element of negative 1 to positive 1. For our last example, it says find the intervals of increase and decrease for the function f of x is equal to x to the power of 2 over 3 times x minus 2 squared. So, just like in the previous cases, our first step is going to be solving the derivative. And for this one, we're going to be using our product rule and our chain rule. So I'm going to get x to the power of 2 over 3 times 2 times x minus 2 to the power of 1 times 1 plus x minus 2 squared multiplied by 2 over 3 x to the negative 1/3 when I take away 1 from 2/3. When I simplify, I'm going to get 2x to the 2 over 3 and x minus 2 plus 2 over 3 x to the negative 1/3 and x minus 2 squared. I'm going to factor this, so I'm going to factor out the fraction 2/3. I'm going to factor out the x with the smallest exponent, x to the negative 1/3, and I'm going to factor out the x minus 2 that is the same in both of them. And I'm going to be left with 3x plus x minus 2 This is going to give me 2 over 3 x to the negative 1/3 times x minus 2. And this is going to simplify to 4x minus 2. And I'm going to pull out the common factor of 2 from that last set to get 2x minus 1. So I have 2 times 2 on the top, so I have 4. I have a x minus 2, and I have a 2x minus 1. In the denominator, I have a 3, and I'm going to move down that x to the negative 1/3 and call that the cube root of x. Step 2 is we're going to do the roots. From the numerator, where we have 4x minus 2 and 2x minus 1, which is going to give me roots at 2 and 1/2. I have the denominator, where I have 3 and the cube root of x is equal to 0, which is just going to give me x is equal to 0 as a root. Because I have 3 roots, it's going to break up into 4 intervals. And then we're going to do our chart. So I have one, 2, 3, 4 intervals. I have 1, 2, 3, 4 factors, and then I have my f prime of x and my f of x. So my factors are the coefficient, 4/3, the x minus 2 in the numerator, the 2x minus 1 in the numerator, and the cube root of x in the denominator. And still f prime of x and f of x. My intervals are when it is less than 0, when it's between 0 and 1/2, when it's between 1/2 and 2, and when it's greater than 2. When I pick a negative number or a number that is less than 0, I get a positive, a negative, and a negative. When I pick a number between 0 and 1/2, like 1/4 or 0.25, I get a positive, a negative, and a positive. When I pick a number between 1/2 and 2, like 1, I get a positive, a negative, a positive, and a positive. And when I go bigger than 2, they're all positive. Which means a positive and 3 negatives is going to make a negative or less than 0. 2 positives and 2 negatives make greater than 0. 3 positives and a negative make less than 0. And all positive make greater than 0, which means in the first interval, it is decreasing, second interval is increasing, third interval is decreasing, and the last interval is increasing again. And then we do our statement. Therefore, f of x is decreasing when x is an element of negative infinity to 0 or 1/2 to 2, and increasing when x is an element of 0 to 1/2 or 2 to infinity.